Hello and welcome to the video on 45, 45, 90 triangles. By the end of this video, you should understand the properties of a 45, 45, 90 triangle, and you should be able to identify the relationship between the parts of those triangles. Let's start with what a 45, 45, 90 triangle is. Just like the name implies, it's a triangle with three different angles, two of which are 45 degrees, and the third which is a 90-degree angle. This makes the triangle isosceles because its two base angles are congruent, and right, because it has that right angle. Well, if it's isosceles, then I know it also has two sides that are congruent. In this case, I'm going to mark them, and when we talk about those sides, those are going to be the length of the legs of this triangle. So I'm going to call this length L and this length L, both for leg. Because I'm calling them both the same thing, I'm basically saying here that those are congruent to each other. We're going to try to find the relationship between the length of the legs and the length of the hypotenuse. So I want to know how long each is over here. Well, in order to do this problem, let's start with a few numbers. Let's pretend for a second here that L was 5. If this leg is 5, then the other leg down here would also be 5. So I can figure out what the hypotenuse is by using the Pythagorean theorem. When I do leg squared, or a squared, plus b squared, my other leg squared, is equal to c squared, I get 5 squared plus 5 squared is equal to h squared. Well, that's 25 plus 25 is h squared, or in other words, 50 is h squared. To solve for h, I would then square root both sides, so h is the square root of 50, which can get split apart into the square root of 25 times the square root of 2, or 5 square roots of 2. Well, if I were to do that a second time, this time with a different measure, I could say that, well, what if L was not 5, but rather it was 7? Well, that makes this leg down here 7 as well. So, using Pythagorean theorem again, a squared plus b squared is equal to c squared. I get 49 and 49, so h is the square root of 98. Well, when I split apart the square root of 98, I get the square root of 49 times the square root of 2, which is 7 square roots of 2. Well, we could do this any number of times to try to find a pattern, but I think you might be able to see it here already. You'll notice here how whatever my lengths of my legs were, when they were both 7, the hypotenuse turned out to be the square root of 2 times more than that. And it happened with the 5s as well. When I had both lengths were 5, the hypotenuse turned out to be the square root of 2 times more than that. And that pattern will hold every time. Just to show that, let's try it one more time, this time with the variables. If I do L squared plus L squared using Pythagorean theorem, I know I'm going to get my hypotenuse squared. Well, L squared plus L squared is 2L squareds, is equal to my hypotenuse squared. So when I solve for hypotenuse, I will square root both sides to get my hypotenuse is equal to, well, the square root of 2 is just the square root of 2, and the square root of L squared is just L. I always get the length of the leg times the square root of 2. This leads us to the properties for a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the lengths of the legs L are congruent to each other, and the length of the hypotenuse H is the square root of 2 times the length of the leg. So in other words, the leg is equal to the leg, and the hypotenuse is equal to the leg times the square root of 2. It will happen that way every single time. Let's try a few sample problems. Figuring out what x and y are. If I know that the leg of this 45, 45, 90 triangle is 7, well, I know the other leg over here also has to be 7. And I know that the hypotenuse is always the square root of 2 times more than that. So if both legs are 7, then the hypotenuse here is 7 square root of 2. Problem number 2, we're going to do the same thing. To figure out what x is here, I'll notice both legs here are congruent to each other. So x is really the length of the leg times the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4. So I really have 3 square roots of 4. And the square root of 4 is really 2, or in other words, x is 6. And let's try one more here. We want to figure out what x and y are. This time, though, I've given you the hypotenuse. We know from the previous theorem that the length of the hypotenuse is the length of the leg times the square root of 2. So what's my hypotenuse in this case? Well, my hypotenuse is 12. That's equal to the length of my leg. Well, that's x times the square root of 2. Now to solve for x, I just need to solve this equation. I can really just divide by the square root of 2. So I get x is equal to 12 divided by the square root of 2. Well, you may or may not remember back to Algebra 1, but when you have a fraction, a square root in the denominator was something that was definitely frowned upon. We do not want that square root down there. We should simplify this. So I need to rationalize my denominator. To do that, I need to get rid of the square root of 2 down there. To do that, I am going to multiply by the square root that's in the denominator. When I multiply by the square root of 2 over the square root of 2, I'm really just multiplying by 1, because that's what the square root of 2 over the square root of 2 is really equal to. So since I'm multiplying by 1, I'm not really changing what this is equal to. But by multiplying by the square root of 2 over the square root of 2, I get 12 square roots of 2 over the square root of 4. And then just to reduce that, we know the square root of 4 is 2. And then 12 divided by 2 here can reduce to 6 square roots of 2. Well, if that leg is 6 square roots of 2, we know the other side here is also the same length because the legs are congruent to each other. So y is also 6 square roots of 2. This brings us to the end of the video on 45, 45, 90 triangles. I hope you have a wonderful day.